All right, 4.4 inequalities in triangles. So first we have the side angle relationship inequality theorem, which says if one side of a triangle is longer than the other side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So in this triangle, if RQ, which is 5 units, is greater than the length of RP, which is 4 units, then the angle across from RQ, which is angle P, is greater than the angle across from RP, which is angle Q. Also, this works if we take the converse. So the converse of the side angle relationship inequality theorem says if one angle of a triangle has a larger measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser side. So in this triangle, if angle A is 40 degrees, which is greater than angle B, which is 30 degrees, then the side opposite from angle A, which is CB, will be greater than the side across from angle B, which is AC. So in our next two examples, in the first one we are determining what is the largest side. So in order to find the largest side of our triangle, we always locate the greatest angle, and the side across from the greatest angle here would be side RS. Now this doesn't actually tell us what the measure of line segment RS is, it just lets us know that RS is the longest side of our triangle. And the opposite of this, we are looking for the smallest angle, so therefore we are going to locate the shortest side, which is 10, and the angle across from the shortest side is angle W. So we also have what we call the triangle inequality theorem, which says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So in order to be a triangle, this must be true. Triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So here, determine if the given measures can be lengths of the sides of a triangle. We have 2, 4, and 5. So we're going to see, is 2 plus 4 greater than 5? And this would be yes, 6 is greater than 5. Now we can see, is 4 plus 5 greater than 2? Yes, 9 is greater than 2. And lastly, we have to see, is 2 plus 5 greater than 4? 7 is greater than 4. So, determine if the given measures can be lengths. The answer would be yes. Now for the next one, we have sides 6, 8, and 14. So we're going to see, is 6 plus 8 greater than 14? Since 6 plus 8 is 14, 14 is not greater than 14, and therefore the measure of these three sides would not form a triangle. So I always like to start here. One of the things that you can kind of do as a trick to make things speed up a little bit is you can always check the two smaller sides, and if the two smaller sides are not greater than the largest side, then it would not be a triangle, and then you would not have to check the other two. But keep in mind that it is important that you still, like in the example A, I did check the two smaller sides is greater than the largest side, but in order to successfully figure out if this theorem is working, you do need to check all three sides. So on the next page, we're going to write an inequality describing the relationship between CB. So here is CB, I'm just going to highlight CB, and then we are also looking at side CA. So to figure out if CB is greater than CA, we need to look at the angles that are across from it. So across from CB, the angle measure is 40 degrees. And across from CA, the angle measure is 20 degrees. So since 40 is greater than 20, then that tells us that line segment CB is greater than line segment CA. So remember, we always say in geometry, don't ever assume angle measures. This is a great example of, even though the side looks shorter, since we're not assuming angle measures and the picture is not drawn to scale, we have to actually do the math. We know 40 is greater than 20, therefore CB would have to be greater than CA. Now we want to write an inequality describing the relationship between angles ADB and angle DBA. So we have angle ADB is this angle right here. And across from angle ADB, the side length is 10. And we also are checking the angle DBA. So angle DBA is right here. And across from angle DBA, the side length is 8. So since 10 is greater than 8, that tells us that angle ADB is greater than angle DBA. Now, for our next example, we are determining the largest side of the triangle, the largest side of the whole figure as one. So in order to do this, it is important that we look at this as two separate triangles. So I'm going to start here with triangle 1, and then I'm going to list the sides from largest to smallest, and triangle 1 only. So looking at triangle 1, the largest side would be across from the greatest angle. 62 is the greatest angle, and therefore PN is the largest side. Next, we have angle P is 61 degrees, which means across from 61, line segment LN would be in the middle, and the smallest side of this triangle is across from the smallest angle. 57 is the smallest angle, so LP is the shortest side. Okay, next we're going to look at triangle 2. And in triangle 2, we can see that 85 is the greatest angle. And so in this triangle, line segment LN would be our largest. 60 is in the middle of the angles, so that means across from 60, LM is in the middle. And the shortest side is across from our smallest angle, which is 35. And across from 35 is line segment MN. So notice in our two lists here, we actually have listed that in triangle 1, PN is longer than LN, and so therefore our longest side has to be PN. PN would be the greatest side. So remember that angles do not determine the actual lengths of the sides of a triangle. All it tells us is what would be the largest and what would be the smallest. And so even though 85 is greater than 62, 62 is across from PN in this triangle, and so we know that it's greater than LN, and therefore PN must be the longest side. So in our next example, we want to find the shortest side of triangle DEF. So I'm going to draw a picture. We have angle DEF. Now angle D has the equation 4x plus 10. Angle E has the equation 5x minus 34, and angle F is 78 degrees. So in order to find the shortest side of this triangle, we need to know the angle measures. And to find the measures of a triangle, we know that the angles have to add up to 180 degrees. So I'm going to add angle D, which is 4x plus 10, plus angle E, which is 5x minus 34. And angle F is 78, and we are setting this equal to 180 degrees. So just combining like terms to get us started, we have 4x plus 5x is 9x, and 10 minus 34 plus 78 is plus 54 equals 180. Subtract 54 on both sides. We have 180 minus 54, and we have 9x equals 126, and 126 divided by 9, we get x is 14. Now, before we can find the shortest side, we will need to find the actual angle measures. So starting with the measure of angle D, we're substituting 14 in for x, so we have 4 times 14 plus 10, 4 times 14 plus 10 is 66. And the measure of angle E, same thing. Substitute 14 in for x, so we have 5 times 14 minus 34, which is 36. So if angle E here is 36 degrees, angle D was 66 degrees, and angle F was 78 degrees, then since E is the smallest angle, 36, across from the smallest angle, which is E, across from that would be DF, and so the shortest side of our triangle is DF. Make sure you guys complete the Delta Math assignment that goes along with this today, and I will see you tomorrow.